with me. All right, ellipses. You know that ellipses are common in the world because the Earth goes around the sun in an elliptical pattern. All the planets go around the sun in an elliptical pattern, not circles. Okay. Picture to the right is the graph of an ellipse. Before we begin to study the relationship between the equation and the graph of an ellipse, we first need to have a vocabulary lesson. We don't do vocab quizzes. Below you will find statements with words underlined. Based on the graph, see if you can come up with a definition of each underlined term. Obviously, the center is the point 1, -3. All right, so let's look at number 1. The points 1, 2. There's 1, 2. That would be right here. And 1, -8 are the vertices of the ellipse. So let's just talk. What are vertices of an ellipse? Yep. The vertices are the farthest points from the center. The 2 points that are farthest from the center. Those of you who are watching the video, if I have to write quite a bit, I'll turn it off. I'll pause it so you don't have to sit and watch me write. Look at number 2. The points -1, -3, and 3, -3 are the co-vertices of the ellipse. So what are co-vertices? The 2 points that are closest to the center, right? Okay. Look at question 3. The length of the major axis is 10. Look at that graph. Can you figure out if the major axis is 10 units long? Where's the major axis? The distance between the vertices. Yeah. The major axis is the distance between the vertices. Now, if you are looking at the notes that are already posted, you will see the author's writing and then you will see my writing small. There's something I want to include right here. If the distance between the vertices is the major axis, the distance, well, let me back up. The distance between the vertices, which is the major axis, has a length of what we call 2a. The distance between the center and a vertex is a. So we're going to write that down. The length, and I'll have to erase this because I'm bleeding over into number 4. The length of the major axis is 2a. So the distance, oh, I told you I was going to turn this off when I was writing. The length of the major axis is 2a. So the distance between the center and a vertex is a. Have you guys learned ellipses? Did you do them in Algebra 2? Nope. Okay. Okay. That used to be in Algebra 3, and since we don't have Algebra 3 anymore, I didn't know if anything got moved to Algebra 2 or not. Okay. So the distance between the center and a vertex is a. We good there? So what is a in this case? A is 5. Right. It's all right. A is 5. Now, while you're thinking about the next definition, I'm going to erase. The length of the minor axis is 4. What's the minor axis? What is the minor axis if its length is 4? Yes. The length of the minor axis is the distance between the co-vertices. Now here's my part, which is 2b. The distance between the co-vertices, or the minor axis, is 2b. So the distance between the center and a co-vertex is b. All right. Distance between the covertices, that's the minor axis, and it's 2b. So the distance between the center and a covertex is b. Are you okay there? Some of you still need a minute to write. I'm going to erase this so that we can read the rest of it. Now let's look at this, this next piece. There are two other points that are labeled on that graph. And you see them, let's see, let's get a better color. You see them here and here. These 2 points are called the foci. It's the plural of focus. From this information, it's a bit far-fetched to expect you to be able to define what these are. So let us, so what? So let us do a little investigation. I think he's got a typo in there. Okay, so what we're going to do is we're going to get your ruler. And we're going to look at this piece right here. We're going to measure the distance from the top focus to one of the covertices. This distance should be the same as what other distance? I'm going to pause. You are measuring the distance as best you can from that point to one of the covertices, either one of those. Measuring it. Let's go to the nearest millimeter if you can. But I get, it doesn't matter. I don't care if you measure in inches or millimeters. It doesn't really matter. The question that you're trying to answer is, this distance should be the same as what other distance? Have you got a distance of that yellow piece? Have you got a length? Now measure this length right here from this vertex to the center. Are those two lengths about the same? Yeah. So here's the deal. This length right here from a focus to a covertex is the distance from the center to a vertex. But what is the distance from the center to a vertex? It's in your notes. What do we call the distance from center to a vertex? A. The distance from the center to a vertex is A. So what we know now, and let me try to get rid of some of this stuff and try to neaten this up just a little bit. The distance from a focus to a covertex is A. It's the same as the distance from the center to a vertex. Now take a look right here. What's this length? No, the distance between a center and a covertex. I know it's 2, but in general, it's B. Yeah, my bad. I didn't explain that very well. That's B. Well, okay then. We're looking right here. Now construct a right triangle so that one leg of the triangle is the distance from the center to the focus. Right there. The other leg is the distance from the center to a covertex, which is this piece right here. And the hypotenuse is the distance from the center to a vertex. Hang on a minute. What? Let's read that again. Construct a right triangle so that one leg is the distance from the center to a focus. Center to a focus. That's this right here, right? The other leg is the distance from the center to a covertex. That's this right here. And the hypotenuse is the distance from the center to a vertex.
Oh, then you need to go like to the 1, 2, from the center all the way up to 1, 2.
But that doesn't make a triangle. But I think he means from the focus to a covertex, don't you think? because the other way you don't even have a triangle. I think you got a little screwed up on that one. All right. Yeah. No. Based on the picture you have just drawn, what relationship must be true about the right triangle based on the Pythagorean theorem? Now, let's look at this. Golly, I just got to keep cleaning this up. I am drawing on it so much. All right. We know that the distance from the center to a covertex is B. We know that the distance from this focus to this covertex was the same as A, right? Now, what we're going to do is we're going to call the distance from the center to a focus C. Now that picture is a right triangle. I'm sure of that. So, what equation can we put together for this triangle based on the Pythagorean theorem? B squared plus C squared equals A squared. You are going to have to be so careful. B squared plus C squared equals A squared. Now, I don't want you to take the time to write it, but just, do you have it pulled up in your notes? I mean, do you have it pulled up? Take a minute and pull it up. Looking at the filled in notes, do you see that the author has written distance from center to covertex squared? You see that? Now let's take a look. What is the distance from the center to a covertex? What do we call that? B. So that part is the B squared. Plus the distance from the center to a focus. And we call the distance from the center to a focus C. So that is the C squared. Now, I want you to understand, I'm okay with his writing on this piece. He said the equals part is the distance from the center to a vertex. But we know that the distance from the center to a vertex is the same as the distance from the focus to the covertex, right? The distance from here to here is the same as the distance from here to here, okay? So I'm okay with what he wrote there. I don't have a problem with it. I had a problem above when you couldn't build a right triangle out of it. So here's what you got to remember, and this is what I have to keep getting straight. A is the semi-major axis. Remember the major axis, the length is 2A. And what does semi mean? Half. So half of the major axis, that's A. Half of the minor axis is B. And then C is the distance from the center to a focus. Okay. Now, let's have a look. Study the equations and the graphs of the ellipses below and see if you can determine the connection between the equation and the graph. Find the center of that ellipse in exactly the same way you find the center of a circle. The center is -2, 3. Right. Center is -2, 3. Exactly the same way as you find the center of a circle. Now, I want you to pay attention to this. Do you see the 4 and the 16 under there? Now, I want you to look at those, and I want you to look at the length of the major axis, and I want you to look at the length of the minor axis, and see if you can figure out the relationship between those lengths and these two numbers. So what? Squared. Subtract 1 from the length? Okay, so what is the major axis? Major axis is 4. What's the length of the minor axis? 2. So, it's all right. So, what can I do? I know the length of the major axis is 4 and the length of the minor axis is 2. How could I come up with those numbers 4 and 16? Square them. Square them. Now, how do you know if the 4 goes under the x or the 4 goes under the y? How come the y goes with the a? Because what did you say? What's parallel? The major axis is parallel to the y-axis? Yeah. So the major axis goes in the y direction, so that number's going to be under the y. The minor axis is parallel to the x, so the minor is going to be under the x stuff. Please also notice in this equation, this thing's equal to 1. It's equal to 1. Now let's go to the second equation. That one's not equal to 1. It's got to equal 1. How do we make it equal 1? Yep. Let's divide every term by 100 and let's see what we get. What have we got? I'll have to write it down here. X minus 3 quantity squared over 50 plus y plus 1 quantity squared over 25 equals 1. All right. What's the center of that ellipse? Is it 3, -1? Yep. All right. Now let's talk about those lengths. What is the length of the major axis? Major? 1, 2, 3, 4, 5, 6, 7, like 7. Now, so what do I do with that number to put it in the equation? What do we do over here? We squared it. Now 7 squared is 49. So yeah, so what we know is the length of the A is what, square root of 50, right? Which is just a hair above 7. And we're okay that the 50 is under the X because the major axis is parallel to the X-axis. What is the length of the minor? Well, I say semi-minor. I should say semi-minor. 5, and 5 squared is 25. The minor axis is parallel to the y-axis, so the minor part is under the y. Are you doing okay so far? All right, let's see what we can do with this one. Identify the following characteristics of this graph. All right. Now, nothing's weird. There's no 7.1 something. What are the coordinates of the vertices? -2, 7. And what? -2, -1? I'm by it. That's right. All right, co-vertices. 0, 3. And -4, 3. What is the length of the major axis? 8. If you look on the author's notes, I marked that out because, oh, whoops. He got major and minor mixed up. He put the minor was 8. The minor's not 8. The length of the major, Wait a minute. Major's 8, right? What's the length of the minor axis? Minor axis is 4. Yeah. So he got those backwards. Coordinates of the foci. Now this is the hard part. Remember, the equation is b squared plus c squared equals a squared. Because remember, the distance from the center to a vertex, which is A, is the longest of the distances. So that's got to be on the equals. So, what is A? A is the distance from the center. So A is 4. See, this is where I always have to stop and just, I don't know. What's B? B is 2. And C is the distance from the center to the focus, which is what I don't know. So we've got 4 plus c squared equals 16. C squared equals 12. Clean up square root 12. 2 square roots of 3? Yep. So C is 2 square roots of 3. Now here's the issue. I got to find the coordinates. Do the foci run vertically from the center, or do they run horizontally from the center? Vertically in this case. So I'm going to go from the center up 2 square roots of 3. How in the world am I going to show that? This, what is the center? Negative 2, 3? How do I show what that point is if this distance right here is 2 square roots of 3? I add 2 square roots of 3 to the y value. So I'm going to write negative 2, 3 plus 2 square roots of 3. The x value didn't change, just the y value, and we added 2 square roots of 3 to it. But we got to go the other way, and we got to go 2 square roots of 3 that way. So how are we going to find that point down there? I'm going to do 3 minus 2 square roots of 3. Now let me show you how you can do that and be real easy. You can do that. The y value is either 3 plus 2 root 3 or 3 minus 2 root 3. Are you okay? Okay, the instructions on mine got cut off, but it says graph the ellipse, identify and label the coordinates of the foci for each ellipse. All right, fine, we can do that. Yours is cut off too? Oh, is it on the bottom of the other page? I need to fix that then, don't I? All right, first question. What's the center of that ellipse? Negative 2, negative 3. Now, which way is this going to run? Is the major axis going to run vertically or horizontally? How's it going to run vertically? Because the stuff under the y is bigger. What is A? What is the distance between the center and a vertex? 5. 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. A minor. What is B? B is 3. So it's going to go 1, 2, 3, 1, 2, 3. Now let's see if I can get some assistance. I'm not sure how to do this because I don't think you started the, yeah, I didn't just work at all, did it? There's a way to do that. Let me see. I don't know where I start. Do I start right there? Start at, oh. So maybe start right here?
No, go down. Go to the dot.
The co- yeah.
Here?
Yep.
Drag it out and then drag it.
Oh, wait.
Start at the top. Yeah.
Okay. Oh, I'm sorry, the people who are watching this, I'm sorry for that little escapade there. Okay. Now, the only other thing we've got to do is figure out the foci. What is A? Can't do that with an ellipse, can I? What's A? Oops. A is 5, B is 3. And remember, B squared plus C squared equals A squared. A is the longest. So I've got 9 plus C squared equals 25. I hope we can figure that one out. So what are the foci? Well, the foci are this far away from the center, going vertically or horizontally? Vertically, because they're along the major axis. 1, 2, 3, 4, and 1, 2, 3, 4. So the coordinates of the foci are at where? -2, 1, and -2, is that -7? We're good? Okay, let's try the same one. Do we need to do this one? Yeah, we need to do this one just because of the foci. Yeah. Where's the center? 1, 0. Does the major axis run horizontally or vertically? Is the bigger number under the x's or under the y's? Under the x's, so it's going to run parallel to x. What is A? A is 4. So the distance between the center and a vertex is 4. 1, 2, 3, 4. 1, 2, 3, 4. And the distance between the center and a covertex is 3. That's not what I want right there. Yep. Snap. That's not what I wanted. Let's just fix that. Let's just fix that. It'll be right there. That's just the coolest thing since sliced bread, isn't it? That's just all right. Okay. That's just an old, you got to remember where I grew up. You just got to remember. So A is 4, B is 3. Now, which of those sides is longest? Which side is longest, A, B, or C? A is longest. So it's B squared plus C squared equals A squared. So we've got 9 plus C squared equals 16. Is that right? Square root 7? Square root 7 from where? From the center. So I got to go out this way, square root 7, and then I got to go out this way, square root 7. Which value changes, x or y? Just the x changes because I'm just moving horizontally. So my foci are at, it was at 1, right? Now it's at 1 plus root 7 or 1 minus root 7. And then the y value did not change. We all right? Listen, let's just take this last one and let's just get it set up into the right equation. And then I know that you can handle it after that. This is not in the equation that we need to graph it. It is in standard or general form. So what do we got to do? Probably, I got a constant. So if I move the constant, I don't want to do that yet. Come on. Huh? I am in a minute. Yeah. Now, here's the deal. When you do an ellipse, what does the sucker have to equal? 1. Now, but also, what do we do? What do we do? There's something I'm looking for here. I'm trying to, oh yeah, never mind. Okay, here's what we're going to do. We're going to complete the square first. Because I had to look back at my notes because all of a sudden I had a brain fart and I couldn't remember what I was doing. Now, we're going to complete the square. So yes, I do want to go ahead and rearrange. So I should have just done that at the beginning, shouldn't I? Ladies and gentlemen, you cannot complete a square unless the leading coefficient is 1. This leading coefficient right here is not 1. So here's what I have to do, and it may have been a while since you've done a completing the square with this. Now the leading coefficient right here is 1, and the leading coefficient right here is 1. Now let's complete the square. What am I going to complete the square with on this first parentheses? Half of 4 is 2 squared is. Now, but here's the deal. I didn't just add 4 to that side. I do have to add to the other side, but listen, what did I add to this side? Keep in mind, yeah, this is 4x squared plus 16x plus 16. I really added 16. How do I complete the square on the second set of parentheses? But I didn't really just add 4. 9y squared minus 36y plus 36. All right, so let's see what we got here. 4 times x plus 2 quantity squared plus 9 times y minus 2 quantity squared equals. Now I divide by 36. I got the cart before the horse earlier, yeah. Now I'm going to divide every term by 36. So now I've got x plus 2 quantity squared over 9 plus y minus 2 quantity squared over 4 equals 1. And there's my equation right there. Which way is this going to run? Is the major axis going to run horizontally or vertically? Bigger denominator is under the x, so this thing's going to run horizontally. Okay? Last page. If you want to go back and graph that one and do all of it, you can, and you can check your work online. We're not going to have time to do, snap. There are 4 of these. We don't have time to do them all. Huh? That's what I'm looking for. Let's do let's do this one. Bless you. I have to see these things. I cannot just do them without seeing them. That's one of the reasons I gave you graph paper. The vertices are negative 6, 3. And 2, 3. That's not exactly straight, but pretend. What does that tell me right there? Is that A or is that B? They're vertices. The major axis is the distance between the vertices. So how long is the major axis? Major, whole thing. Major axis is 8, so A is 4. No, it's okay because I'm the same way. I really have to stop and think about these and remember what stands for what. Totally fine. The covertices are negative 2, 5 and negative 2, 1. Because the distance between the covertices is 4, so B is 2. Good. Where's the center? Yeah, it's right there. Negative 2 what? Negative 2, 3. The center is at negative 2, 3. Let's write an equation. Now, is the bigger denominator going to be with x or is the bigger denominator going to be with y? How come? Because the major axis runs horizontally. So it's going to be what, x plus 2 quantity squared over something plus y minus 3 quantity squared over something equals 1. Now what are the somethings? These are squared, 16 and 4. Yeah. All right, now listen. I would really encourage you to go and work those. They're on your